Okay, it's math class, not English class. We're going to observate some stuff. Okay, so the thing we're going to observate is this kind of weird idea that I was like, in the writing down the fundamental theorems, right? We came into this like, well, can you like back out of multiple curl and divergences like in a string or something? So this leaves me with this idea of like, what if I start with a function f, right? Like a scalar function. If I take the gradient of it and then take the curl of that, you guys see that? Like this would be, okay, I'm going to start with a scalar function and I'm really thinking like, okay, this guy here is something like I get out of, like that's something that you feed into the fundamental theorem of line integrals, right? And this guy is something that you feed into one side of Stokes, right? So this is the apply Stokes and then try to apply the fundamental theorem of line integrals. You guys see that? So like, let me just think about what kind of function I would get out of this. You guys with me on that? So, I don't know. Let me start with a function f.
I would just.
If I take the gradient of it, what do I get?
It's kind of f prime.
Yeah, it's kind of f prime, but specifically, what is it?
Oh, it's a vector. Okay. So
It's a vector, right? And it's made out of?
It has to be made of 3 variables because we're about like the curl toy. Is that what you're trying to get at?
I was thinking more like, what the heck do you actually get? Like, how do you calculate a gradient of something? Yeah, you take the partials with respect to x, partial with respect to y, and partial with respect to z, right?
Okay.
So you get here the partial of f with respect to x, the partial of f with respect to y, and the partial of f with respect to z, right? And then you take the curl. Right? This is scalar multiplication, yeah? Just out of curiosity, what happens when you take a vector and cross it with itself?
Oh, you get normal, or you get 0.
You get the 0 vector, right? And then if there was scalar, if you take a vector and multiply by, or in cross product with a scalar multiple of itself, what do you get?
0 vector.
The 0 vector. I'm not going to make you guys go through this calculation, but if you did, like if you actually wrote down curl of this crap, you would get the 0 vector out. Well, with minor assumptions. The minor assumptions you'd need are basically chloros. Right, because you'd want to know that if you take a partial with respect to x of the y partial, you would get the y partial of the x partial, so that they would cancel. So there's some assumption here to get the 0 vector out of this, which is basically that this dot product didn't do some weird crap. Right? But this is true in any kind of normal, nice function case. You have to have a really pathological function for this to follow.
That makes sense intuitively.
Yeah, and it should make sense kind of a little bit intuitively. You're taking 2 derivatives, right? Somehow we got 0 out of that. That's a little weird.
Well, I meant the curl of grad. Like grad is the fastest possible way you can move down or up the slope. There's not going to be any swirlies going on if it's the fastest way.
Okay, sure. That's kind of reasonable. You guys see that? Like there's no eddies in the fastest way downhill. That's kind of what this is saying, right? In other words, if you try to apply Stokes and then apply the fundamental theorem of line integrals, you're going to get nothing. right? You guys see that? Okay, so let's try the other one. Because there's another one that you might try, the divergence of the curl of F. Right, you take a vector field, feed it into Stokes, and then feed that into the divergence theorem, right? Or really, sorry, do the divergence theorem and then feed it into Stokes. So this would be divergence theorem followed by Stokes. Well, okay, so this is the gradient times the gradient crossed with a function, right? So we should be able to use a little geometry to help us out here. What's a cross product between two vectors? It's a vector that has a magnitude that's the area of the parallelogram that points in which direction? Perpendicular to the two vectors you started with, right?
It's dotted, which means it's going to be zero.
You guys see that? This thing should be perpendicular to both gradient and f, whatever the hell being perpendicular to the gradient means. Well, I have a definition for perpendicular. You guys remember when we defined perpendicular to be that the dot product was 0?
Oh my goodness.
Oh. So if it's perpendicular to the gradient, that means when you dot that result with the gradient, you're going to get 0. What category of 0 do you get out of this? Is it a vector again?
Oh no, it's a scalar because it's dotted at the end.
Good. It's the 0 scalar, right? Which again tells you, like, if you try to apply the divergence theorem and then try to apply Stokes, you're not going to get anything useful.
You get even worse than nothing.
You guys see this? Like, this is just daisy chaining these theorems together is going to give you nothing because the kinds of objects that you're applying them to, the boundaries on those objects are always 0. You guys see that? Like, if you have a surface that bounds a region, and then you would apply the divergence theorem to that kind of thing, right? You would get a surface that doesn't have any holes in it. It's not missing a chunk, right? That's that blanket problem, right? Like, you don't have a blanket anymore. You have a whole surface. So then you try to apply Stokes to that. Well, it doesn't have any boundaries, so you integrate over 0 anyway. And this is just saying, yeah, hey, the integrands are going to match. You guys cool with that?
So Stokes requires that the curve be closed, and if you do FTLI on a closed thing, it's always 0. If you can even do it.
Yeah. Yeah, right. The fundamental theorem of line integrals applied to a closed curve is 0. In other words, the only time these will ever be interesting is when you can't find the gradient, or you can't find. Does that make sense? Like, if you can do 2 steps of anti-differentiation, it's not interesting because it was the 0 thing to kind of start with, right? You guys see that? Okay.